In this session, we're going to go over Chapter 9, a little bit more about hypothesis testing. We're actually going to show how to do it with hypothesis testing with two samples, which would be what you would do if you were comparing one group that had a treatment and one group that didn't have a treatment to see if there was a difference in the results from that. So, without too much more introduction, let's just go ahead and start looking at this. In the material, we have several different situations that can arise. For example, we might have a situation where we want to compare the proportions from one group to another. And in the book, we have a test to compare the estimate of proportion 1 from an estimate of the group from the second group of the second proportion. And basically that just uses a z-score to make that comparison. It's very similar. When you see that, it's very similar to the one that we gave in the previous test. I mean, the previous chapter, using one proportion, and we get those just from the calculations of x number of successes over the number of the number of trials there. Also in this chapter, we have the test that's a t-test and a z-test to compare the mean from one group to the mean to another group. And so these are just independent groups. We give a treatment to this one and they score and then measure some value, the blood level or something like that, and or their improvement. Then this group would be the control group that wouldn't have an improvement, or would be the status quo group. Now, in this situation, we can go through and there's two different possibilities with the means. And that would be if the variance is known or the variance is unknown. Now, the majority of the time, this will be the situation. And that typically uses the t-test. There will be some situations where the variance will be known. It's been studied enough to where it can be assumed, such as in IQ scores or something like that. And then you would use the z-score. Now, because this is a rare situation, I didn't put a whole lot of information about that in the material to be studied for the test. So most of the time, and in most of the literature, they're going to use the t-test, even if the z-score could be used. And the basic difference is this. If this is the z-score distribution, you're going to find out that the t-test is just a little bit different, like that. And so most of the time, especially if the sample size is larger, these get closer and closer together. So as the sample size gets larger, these two values, the z-score and the t-score, get closer together. So as a result, most of the literature just ignores the z-score situation and uses the t-test. Another thing that you're going to find in this chapter is paired, matched, related samples. And there's several ways that you can go through and do these. For example, if you go through and you give a pre-test and a post-test, that would be a situation where we would use a paired sample. You measure blood pressure in one arm and blood pressure in the other arm, and that again would be maybe a way to match those up or pair them up. But you can also do it in a little bit different way with matching people. For example, you have a group of people here, and you want to go through and do something maybe on the weight loss. So you can take somebody that weighs 200 pounds here, somebody that weighs close to 200 pounds here, and match them up. Okay, so this guy's in one group, this guy's in another group. They're matched, and so if you put these guys on a certain treatment or exercise regimen, and he loses 10 pounds, but this guy, the status quo, doesn't lose 10 pounds, then you've got a difference in that matched pairs of, some value. In that case, 190 and to 200 would be 10. And so they don't have to be the exact same person. It's just at the first of the study, you go through and you match them up so that they would be matched in that situation. And there is a way to go through and use, again, it's a t-test. And in fact, that t-test is very close to the t-test that we used in the previous chapter, because it just uses one value, the difference, and compares that to 0. Also in this chapter, you're going to find out that there is some material there on comparing variability. Is the variance in one group equal to the variance in another group? So, towards the end of the chapter, or in the material, the Moodle material that goes along with the book, you're going to see this type of a chart. It's not always going to work, but it's going to be a very good first start at identifying which test you should